So picture this. You just pushed a new feature, and now it's time to test the API. You open up Postman, hit send, and you kinda eyeball the response. You tell yourself, yeah, looks good. But what if looks good is actually a lie? That quick manual check you just did? Well, that's exactly how those subtle, really costly bugs sneak right past you and into production.
I mean, think about it. You've got a dozen endpoints to check after a new deploy. You're clicking send over and over, scanning this huge wall of JSON, and just kind of hoping for the best. But let's be honest with ourselves. Looks good isn't a test. Not really. It's a gamble. And when you're gambling with your API, you are betting against a production outage.
Because here is the really uncomfortable truth, the one that every single developer learns the hard way. That little green 200 OK status, it can be incredibly deceptive. All it really means is that the server got your request and didn't completely crash. It tells you absolutely nothing about whether the data it sent back is correct. It's just a handshake, not a guarantee of quality.
Okay, so let's build a system to stop gambling and start actually verifying. We're going to start with why that 200 OK is such a problem. Then, we'll write our very first assertions, chain requests together into real-world workflows, and finally, we'll automate the whole shebang to catch even the sneakiest of bugs.
Right, let's dive into that central problem. See, an API isn't just a connection. It's a contract. It makes a promise to deliver data in a very specific shape with very specific values. A 200 OK just tells you that the mail was delivered, not that the package actually contains what you ordered. And this is exactly what I'm talking about. A successful HTTP transaction does not equal a successful API call. Just imagine your front end gets a 200 OK, but inside the data, the user's email is null, and their ID is just gone. To your app, this API is completely broken, even though Postman is sitting there showing you a happy green status. So the solution is right inside Postman's Tests tab. This is basically a little JavaScript environment that runs after the response comes back. This is what lets us use code to check if the API is holding up its end of the bargain. This is where we stop just checking and start testing.
You're going to get to know two key functions here, pm.test and pm.expect. Think of pm.test as the container for your check. You give it a clear, human-readable name, like status code is 200. Then, inside that container, you use pm.expect to do the actual check, to see if a value, like the response status, is exactly what you think it should be.
All right, let's write our first one. We just hop over to the Test tab, we write pm.test, give it a name like status code is 200, and inside we assert that pm.response2.have.status 200. When we send the request, boom, we see it passes in the Test Results tab. But watch this. If I change that expectation to 201 and run it again, it fails. We now have an automated, repeatable check. It's that simple.
Now, just checking the status code is only the beginning. A really solid test suite validates that entire API contract, and that means we need to be checking 4 key things. First, the status code. We just did that. Second, response time. We can actually write a test to make sure the response time is below, say, 500 milliseconds to catch any performance problems early. Third, and this is the big one, specific values in the body. We can parse the JSON and check that a user's ID is exactly what we expect it to be. And fourth, the overall shape of the data, the schema. Using JSON schema validation, we can make sure required fields are always there and the data types haven't changed. No more of those null field errors we talked about earlier.
Okay, so let's build on that. Real-world apps aren't just a bunch of single isolated requests, right? You log in, you get a token, and then you use that token to actually get some data. Well, Postman test scripts are absolutely perfect for automating this entire flow.
And the secret sauce here is using Postman environments. You can think of an environment as just a little bucket of variables. We can use code to grab a value, like an auth token, from a response, save it to the environment, and then just reference it in all the requests that come after. This is where the magic happens. In our login request, we go to the Tests tab, and we grab the token from the response body. Then, with just one line of code, pm.environment.set token, response JSON token, we save it. Now, for our next request, the one that needs authentication, we just use the catch tag token variable in the auth header. Postman handles the rest, automatically plugging in the value we just saved. Pretty cool, huh? Okay, we've got our tests. We're chaining requests. But clicking send on 10 different requests, one by one, is still manual work. Let's automate the entire suite. And for that, we turn to the collection runner. The collection runner is basically Postman's built-in automation engine. It's super simple. You just pick a collection of requests, click a run button, and it will execute every single one in order from top to bottom, and along the way, it runs every single test script you wrote for each of those requests.
And this is the payoff. You get this beautiful, clean dashboard that gives you a complete health summary for your entire API. You can see every request, its status, how many tests passed or failed, and even the response time. This is your personal, automated regression suite, giving you instant feedback after every single code change you make.
All right, let's put everything we've learned together and use it to solve one of the most maddening problems in software development, the intermittent bug. You know the one. It sometimes happens, and it's basically impossible to reproduce when you need to.
So imagine you get this bug report. A customer's payment status is stuck on pending when it should say completed. The developers have tried to track it down, but every time they look, it seems to work just fine. This is the perfect job for automated, repeated testing.
So here's the game plan. First, we create a simple request for that /payment status endpoint. In the Tests tab, we write one simple assertion. We expect the status field in the JSON response to equal completed. Then, we open up the collection runner. But here's the key. Instead of running it once, we're going to crank up the iterations to 10 or 20 or heck, even 100.
We click Run, and we just let Postman do the heavy lifting. And there it is. 9 of the runs passed without a problem, but on the 7th try, the test failed. We can click right into that failed run and see the proof. The response body shows the status was pending. We did it. We caught a ghost.
The value here is just huge. You've just turned a vague, frustrating bug report into a perfectly reproducible test case. You can actually export this Postman collection and hand it straight to the development team. They can run it themselves, see the failure with their own eyes, and that saves them countless hours of debugging and guesswork.
So, what's the bottom line here? First, stop trusting that 200 OK. It's not a real test. Second, start writing assertions that validate the whole contract, status, performance, values, and the data structure. Third, use environments to chain your requests into real user journeys. And finally, automate everything with the collection runner so you have a regression suite that does the boring work for you.
And that really brings us to the final question, doesn't it? With these tools, you now have the power to look way beyond the surface of a simple success status. So, what critical bug, what silent failure is hiding behind a 200 OK in your API today? Well, now you know exactly how to find out.